Hi, I'm Atdhe. Over this video, I'm going to demonstrate how we would be mounting and exploring an IoT disk image. So that can be any type of file system, exe3, FAT, doesn't matter. So the objectives would be that safely mount as read-only a disk image. So that is very important when it comes to the digital forensics. So that would be something, and then how we would inspect the metadata. So let's do that. So as a prerequisite, we're going to need for a small image file, potentially an IoT device image, FAT or ext, doesn't matter. I created one for the purpose of this demonstration that I already got. So that would be something. And I'm just going to navigate to this location with the terminal so we would be able further to demonstrate that whole mounting and as a read-only and exploration. So the first step would be, so we're going to make a directory that would be mounted as analysis. So that would be something as a first step that we would do. And then the second step would be mounting an image read-only via loop. So that would be something next that we would do. Sudo mount, we would ask for permission, and -oro. This would be that command that would prevents writes. So that would be something that we will be looking. It's important when it comes to digital forensic and examination. So we don't want to contaminate the evidence within our writing. Whatever we would be mounting and trying to explore further, we're going to have this read-only mounting options all the times used. If you would have in between a bridge, write blockers, that would serve the purpose, and that would block that whatever comes as a write action step. So this would be, and then we're gonna mount in the next mounting path that we mounted. So this would be, so we mounted this. Let's see. So we mounted, and we have this structure of this IoT device. So it have all that structure of the file system, etc, home, lost and found, user, var, and so on. So that would be the steps. And whenever what we did, investigate, extract, and analyze all those evidences, whenever we want to done with this, that would be sudo umount, and that would be the mounting that we already, so that would be the safest way to do it. So this would just unmount that whole. So this was all about mounting, safe mounting as a read-only, which is very important in digital forensics, and then for exploring the IoT disk image. Next, let's see more on the sleuth kit. So there is a kit that looks on inode level view. So this would be an objective showing inode metadata and recover a file by inode. So how are we going to do that one? Let's clear this terminal for a moment. So FLS would be that command that we would be using on this IoT device image that I made up for this demonstration. And that would just show the recursive list of entries would return. And if we wanted to see more on the istat of this IoT device, so that would be displaying more info. And that would be what kind of info we will be using. So istat, we have a lot of usage commas that we're going to use that again. So fs without mounting, so there wouldn't be a need for mounting. You see, it's an image file that we already did. So that would just show that whole structure and would show istat would be able to show size, timestamp, reads raw content by inode. So that was the whole objective, showing how we would be using the FLS sleuth kit to showing an inode. Next, what we'll be looking on the demonstrations where we want to build an MACB timeline, modified access, change, birth, or created timeline by using a sleuth kit. So we're going to use the mactime. So that would be something that we'll be using. And let's try that to build. So this would be that IoT device image. So we're going to build this body file, txt, that would be created. And let's just see that one. But at this moment, we will just generate that body file. If we would be seeing that body file, cat, that would be something that would not be so much understandable and would not be very well prepared and designed. But let's use the mactime. As we said, sleuth kit would have a lot of useful tools that we can use. And we want to have this body file generated into a timeline txt. So that would be converting to more human readable. And that is done. Let's just inspect that one. That would be timeline txt. So that would be something that will be looking something like this. And let's see what we have. So we have all information structured comparing with the previous body file that we created. So that would be a structure that will help us so much in further investigations. And then if we want to just grab something that would be, for example, let's assume that would be mosquito, and we would combine. We want to combine. So mosquito log conf within a timeline txt, and that would be found. So whatever would become as a combination of those grep filters that would be able to show us. So this would be important information, that important way and methods to use when we inspect more further into those keywords list that we already created. Those would be in our interest for our case. And then we would just be able to have that by using the mactime structure that would be more converting more human readable timeline by using a sleuth kit. So this is a sleuth kit. You can do this timeline construction building with Autopsy, with a GUI, with a different operating system, Windows, Linux, whatever you prefer. And then if we wanted to inspect more on interesting periods and combining those grep filters, you would be able to do so as we did it. And FLS would export those metadata. Mactime would render those chronological MACP lines. Within the next video, I'm going to demonstrate using the Autopsy GUI within a Windows environment. So I'm going to try to demonstrate and show where we would be able to find the evidence and the metadata of the evidence and building a timeline. And I'm going to try to describe the whole that timeline in the meantime that this Autopsy case is being opened. So we would navigate evidences within this GUI of the graphical user interface of the Autopsy. I'm going to try to figure it out. What was that MHP, modified, access, changed, and birth or created, timestamp associated, related with the file. So that would be most important for us. And what would be the first step at the beginning? So we're going to start Autopsy, having that new case created already, and then just adding those data resources that we want to have that evidence looking more in deep into it. So that would be something. And the next would be, we want to see that whole that timeline construction. After all those examination, extractions, evidence that we got, we would be able to do that. Or we would just do in the first place that we just got that source, that disk image that we want to investigate, and that we would be able to do by having that viewing the timeline construction. So that will be mostly the focus over this video demonstration. So we have our case open and it's already there. Let's see on a data source, and we have that evidence, that image file that we already got from an IoT environment. So that would be the structure of that whole image showing here. So that would be assuming would be ext4, 3, or FAT, doesn't matter so much. And then we have some analysis results that we did already, and we hit at some keywords that we would be interested mostly. So IoT, mosquito, MQTT, PI, all those would be important for us for our investigation. And each one of those got some results. So IoT got very useful files as potential evidence, and MACB is here, MAC, and a B would be the moment where this file would be created. But let's look more in deep on this timeline construction. And this would be that timeline. So the timeline is a view all the activities that was happening within this evidence, this image file, in this case, an IoT. So Autopsy would display for us a visual timeline of file activity derived from MAC, modified access change timestamps. So we would be able to filter by time or folder And then using those filters, adjusting in that moment of time where we will be mostly focused on the investigation would be showing a different file paths. But let's explain that and let's demonstrate that and explain the forensic values that this would reveal for us. For example, here we would have the timeline, and here we would have the timeline that we would be able to adjust whatever would be our needs. So we would be able to move this around. Where would be that moment that we would be interested mostly? So let's assume that would be this moment in the time, which would be in January, and we're going to look that in the particular moments. That would be something. Whenever you click on one or the other, you would be able to know. But mostly we would look this view mode on the details where we want to know all the details. So in this very moment, there was something was happening. So all the events that was recorded was related to this reference to those paths. etc, home, and var. Let's see one on the var. So we see that on var there would be some files created and then shown here in the table. So the whole window of the timeline is constructed that way that has all those panes. So in the lower pane on the left side, you would have the files that shows that what was the event type. And each the timestamp, so you have date and time as important timestamp. We reference everything our investigation from a timestamp. And then we would see where was that path and that file that was referenced to this timestamp. And then what was the event type, file accessed, modified, MAC. And then on the right hand, on the right side of this pane, you would see the content within this file. You can see either hex, or hex view. That would be something that different people will use, investigators, and text. And of course, most important, file metadata, the focus of all this demonstration. So you would know where was modified, accessed, changed, created, what kind of hash algorithms are used, and so on. So each one of those would produce a lot of evidence. And this way you would have that evidence and you reference that timeline. But let's just assume and let's see that if we want to investigate the whole that timeline, that we already have this all evidences. And the view would be like this. There would be more items showed within the timeline that would show the moment where those lost and found, for example, or let's go to the etc, for example, and then let's try to figure it out. What was a gateway broker that was collecting all those evidences for all those sensors, IoTs that we use? And that would be showing here. So mqtt.conf would be that configuration file that would help to run that gateway. And here we would have some IP addresses. In case we missed and we didn't know where was the gateway broker located, with this IP address, we would be able to go back and investigate that further and grab that image of that whole environment actually. And we would see that it's running on the port 8083, a typical MQTT commonly used port. So MQTT is a protocol that is used in IoT for communication. It has that way of communicating and operating publisher and subscriber. And topic, it works with a topic. Topics would be IoT, and device one is the name of the IoT sensor that is already subscribed to this publisher, this gateway. And then if we want to know more on the Mosquito, the whole engine machine that gateway is running and trying to collect those files, those data from sensors, we would be looking here, that too. So as a forensic value, this would reveal a lot of device activity order. So that would show us first a timestamp, and then all the files related to the timestamp would be listed and the paths too. So if we want to deep dive more on the details on each of those files, we would know where to find, and then we would be able to right click and extract those files and have those, or select rows to CSV, export those to CSV. You would be able to do a lot of those things that, and further, you would step in on a file carving and a lot of evidence extracting and trying to get out most of it from that evidence.